Hello everyone, welcome back to the channel. Today we are doing lead code 1865 finding pairs with a certain sum. So it says you're given two integer arrays nums1 and nums2, alright, which is given to you in the form of this constructor nums1 and nums2. What it's saying is you have to implement some sort of procedure, and what that procedure is, there are two types of functions, two types of you can say modules that you need to implement. Add a positive integer to an element of a given index in the nums2. So nums2, there are some number of elements which are present, for example index 0, index 1, index 2, so on and so forth. What you are supposed to do is at a certain index add this particular value. So for example, if this is my nums2 and it says that go at index 2 and add the value of 10, so 5 becomes 15 in that scenario, all right, something like this. So this is function number 1. Function number 2 is count, and you're given a value which is known as total. Now what you have to do is you have to count the number of pairs I comma j such that nums1 of I plus nums2 of j equals that given value of total. Means, for example, if the total is given as 7, then you can see if my I is over here and my j is over here, then 2 plus 5 is equals to 7. Similarly, 2 plus 5 is equals to 7. And then similarly over here as well, for this 2 you will have two choices, right? And then for this 2 you will have these two fives again. So this makes a total of 6 pairs. And then if your I is over here, then you can see 3 plus 4 is 7, and then 3 plus this 4 is 7 as well. So this makes the total number of pairs out to be 8. So these are the two functions that we need to implement. Now the constructor part is very easy. You just declare two arrays a and b, and whatever nums1 and nums2 is given to you, you just sort of store them inside of a and b so that you can use them globally outside of this constructor scope as well. That's it, right? Now if we think about the brute force approach, no clever technique, no nothing, just the most simplest way to solve this problem, it would be that we do literally what the question tells us to do, right? It tells us to add a positive integer to an element at a given index, so we are going to do just that, nums2 of index plus equal val. And then similarly in the count module, it tells us to find the number of pairs such that nums1 of I and nums2 of j equals a given value. So what I'm going to do is I'm going to use nested loops for int I equals 0, I is less than a dot size. Now we need to keep in mind that a dot size and b dot size, they're not the same values, they can be different, and the constraints for them are different as well. So nums1 dot length at maximum can be 10 to the power 3, whereas nums2 dot length is bigger, it's 10 to the power 5. It can at maximum go to 10 to the power 5. So what I'm going to do is I'm going to do something like this: j is less than b dot size j plus plus. So what I'm basically doing is I'm iterating over uh, all the possible choices that I have. So for this particular I'm going to iterate over all the possible values of j. Then I'm going to do the same for this particular I. Then I'm going to do the same for this particular I. So this gives me a time complexity of O of n into m. Why? Because for each and every single individual element in nums1, I'm iterating over the whole array of nums2. Right? This is nums1 and this is nums2. So let's do that. What we are going to see is if nums of if sorry not nums if a of I plus b of j, if it's equals to the total that is given to us, what we are going to do is ans plus plus. Let me initialize the answer variable as well over here, and over here we are going to return whatever the answer is. So if we run it on the test cases, oh sorry, this is supposed to be b. If we run it on the example test cases, let's see if it passes them. It does pass the example test cases. Let's see if upon submission it passes the overall test cases. It does not. It says time limit exceed. Now let's take our time and let's analyze why does it give us time limit exceeded error. Okay, all right. So you can see that nums1 dot length can be 10 to the power 3 and nums2 dot length can be 10 to the power 5. So that means that 10 to the power 3 into 10 to the power 5 gives us 10 to the power 8. Now this is acceptable, right? This is acceptable if we are just making a single call to the count function. But then if you observe over here, they're saying at most 1,000 calls are made to add and count each. So they're saying you are going to call the count function 1,000 times. And if you do, so 10 to the power 8 is the time complexity when you call the count function a single time. When you call it 1,000 times, it gives you a time complexity of 10 to the power 11, which is obviously which is not under the acceptable time limit, which is 10 to the power 8. So now let's think about how we can optimize this. You see, if we think about it, nums1, the size of nums1 can be at maximum 1,000. Okay. Now, n into m is not being accepted. N into m is not being accepted. So you see, we are given a total and we need to see how many pairs out of nums1 and nums2, how many pairs make this certain total. So if I take this particular I, what does that mean? It means that I need 1 plus some nums2 of j to be equals to this total, which is 7. What does that tell me about nums2 of j? It tells me that nums2 of j can only have a single value, and that is equals to 6. So I don't need to search every value inside of nums2. No, I only need to see how many instances of 6 I have. There can be more than one instance, right? So let's take another example. For example, if the total for me is given as 7, okay, and my I is over here. So I need to see 2, nums1 of I is 2. 2 plus nums2 of j equals 7. So nums2 of j can only have a value of 5. Now, how many 5s do I have in nums2 of j? I have 2 5s. So what is one efficient data structure that can tell me the frequency of 5 directly without having the need to iterate? That is a map, because a map can very easily sort of store the frequency of each element. So you have one time, you have 4 2 times, you have 5 2 times as well, and then you have 2 just a one time. So when I'm standing at this particular index, I am looking for a 5 in nums2, and this map actually tells me that you only have these 2 instances of 5. So this means that this particular index is going to give me 2 valid pairs. Similarly, this is also going to give me 2 valid pairs, and this is also going to give me 2 valid pairs. I'm just going to repeat the same process for each of them. So in total, 6 valid pairs. Now, when my I reaches this point, what am I going to say? I'm going to say 3. I'm going to say 3 plus nums2 of j equals 7. That means nums2 of j can take a value of 4. And I just have, I have actually have 2 4s over here. So similarly, it means that this particular 3 can be paired with this 4 and can be paired with this 4 as well. So 6 plus 2. And where am I going to get this 2 from? I'm going to get this 2 from the map over here. So it's as simple as that. But then there's one little detail that we are missing right now, and that is that certain for a certain index value, you can increment that value by a certain amount, right? It says that in the add module, in the add function, what you need to do is basically you need to do nums2 of index plus equals val. So for example, if I have, let's say, this particular function call, let's say 3 comma 5, then what this does is, this is index 0 1 2, this is index 3, and this is basically the current value. What it's going to do is it's going to go at index 3 and it's going to increment this by 5, so it becomes 7. Now since this becomes 7, it was previously 2, right? I need to go and I need to reflect that change inside of my map as well, inside of my map as well. So first what I will do, it's very simple. You see, initially it was 2, so, and that can be seen very clearly in my map as 2 has a frequency of 1. So since the 2 is being changed, since the 2 has now become 7, what I'm going to do is I'm going to decrement the frequency of 2. It becomes 0. Now since the frequency becomes 0, we can sort of erase this element out of our map entirely. And then since this 2 has become 7, what I'm going to do is I'm going to increment the frequency of 7. So basically, in our new logic, we will no longer be actually working with nums2. We will actually be working with the map mostly for the count module. But then that doesn't mean that we won't be updating the value in nums2. We will be updating the value in nums2 as well as in the map. So let's see how this can be taken into code. Okay, so let's see how this strategy can be implemented into code. But before that, let me clarify this one thing. This question should have come up into your mind, that why are we choosing nums2 in order to populate the map and why not nums1? It's because the maximum size of nums1 can be 1000, right? So over here what we are doing is, for each index of nums1, so for, let's say, for this particular value, I see 1 plus nums2 of j equals 7, so nums2 of j will be equals to 6. And similarly, I'll increment my I will increment my I will increment my I. So what we are basically doing is we are iterating over the whole of nums1. Now, if I had done the opposite thing, if I had used nums1 in order to populate the map, I would have had to iterate on the whole of nums2, and that would have meant 10 to the power 5 iterations. In this scenario, what we are doing is at maximum 1000 iterations. So you can obviously think of which one is the better choice to go with, right? So again, now why I'm sort of telling you this thing is because for each choice that we make inside of our solution process, the intuition, the reasoning, the logic behind that choice should be very much clear to you, right? So let's see how we can do this. Let's first implement the count function. So we are given a certain total, and what basically, see, what do we find out inside the map? Let's say that my I is standing at this position. It tells me that 2 plus nums2 of j should be equals to 7. Now what should I look inside the map? I should actually look for 5 inside of the map, which I will find over here. So it means what I'm looking for inside the map, the remaining value is what? It's total minus nums1 of I, isn't it? And that is going to come inside of our inside a for loop, because we are obviously iterating uh, over the num over the nums1 array, which is a in this scenario. So what I need to look for is total minus whatever the current index value is, right? And I'm going to see if it is present inside my map or not. So if mp dot find the value of loop, if it's not equals to mp dot end, that means it has a certain value, and I'm going to, whatever that value is, so if it's 2 or if it's 3, you see it's 2 right now. I have 2 5s. That means that this particular 2 can be paired up with this 5 and this 5, and both of these choices are going to make 7, right? So what I'm going to do is I'm going to say mp of look over here. Similarly, let me go up and initialize the answer to 0, and what we are going to do at the very end is just return whatever the value of answer is. So there is our count function. Now the add function, let's say what happens in this scenario. If for example I have let me go back a little. If we have, if for example I get this particular value called 1 comma 1, that would mean that the number which is at index 1 in nums2, this 4, is no longer 4, it needs to be made 5. So this 4 is no longer 4, but it needs to be made 5. So first of all, what I'm going to do is I'm going to see which number they're talking about. Okay, so which number you're talking about? Int number is equals to b of index. All right, so we are talking about 4. This particular 4 is now stored inside of my number. What I'm going to do is I'm going to go inside the map and I'm going to reduce its frequency by 1. All right, sure. So I do that. As soon as I do it, I realize that 4 has become 0, so we can actually remove it from our map, right? Let's do that. If mp of number, if it has become equal to 0, just erase the entry from the map entirely. All right, so what that will do is that will erase 4 from the map entirely. Now since 4 is erased, now we need to do the update logic. What's the new number that we have? The new number, is the previous number basically plus the value. Which value? Which value? The value which they have given to us. What we are going to do is first of all MP of new number plus plus. So we are going to, whatever the new number is, in this case it's 5, we are going to increment its value, its frequency. So it becomes 3. And then we are also going to change in, we are also going to make this particular change. So we erase the 4 and we write 5 in the place of it. So how can we do that? It's very simple, obviously. B of index is equals to what? Is equals to the new number. That's it. Let's see if it passes the example test cases. It does not. MP of number minus minus, which I did not take an unordered map over here. I should have taken it. Int comma int MP. And one more thing that I'm actually missing is the initial population. I will have to populate the initial map, right? So I can do that something like this for int I in B, MP of I plus plus. This is the initialization step, which I actually totally forgot about. So we have to keep that in mind as well. Accepted. Let's see if it passes all the other test cases. And it does. So let's see what the overall time complexity of our solution is right now. So the count function, if we talk about the count function, then the count function is just an O of n operation, right? Why is it an O of n operation? Because you're iterating over nums1, and basically this n is nums1 dot size, right? We are iterating over nums1 array, and what we are doing is we are sort of looking for a value inside of the map, if it exists or not. So that's just an O of 1 operation. So inside each of the operations, we are just doing this O of 1 thing. So overall the time complexity for the count function has become O of n. And similarly, the add module is actually an O of 1 operation, because we are not actually iterating or anything, we are just doing in place changes, right? If we talk about the space complexity, then the space complexity can very easily be as seen over here. It's O of n, because we are taking this extra map and these two A and B vectors over here. So yeah, I hope you found the video helpful, and I'll see you in the next one.